Okay. CH to CH to CH. So this is called propane. Propane burns in oxygen to form CO2 and water. It's balanced. Right? Right? Propane plus 5 moles of O2 product, 3 moles of CO2 and 4 moles of water. Right? 4 moles of water. Okay, now let's find the oxidation states of carbon. There are 3 carbon. So this carbon is marked as X and this carbon is marked as Y and this as Z. Right? X, Y, Z. Hydrogen, you don't need to mark hydrogen. Why? Its oxidation state is always +1 or -1. When they are combined with metal in a binary compound, the oxidation state of hydrogen should be -1. In all other instances, the oxidation state is +1. So here, what's the oxidation state? +1. Why? It's not a binary compound and also there's no metal. So the oxidation state should be +1. Right? +1. Hydrogen is +1. What about carbon? Oxidation state of carbon. X carbon -3, Y carbon -2, Z carbon again -3. Got it? X carbon -3, Y carbon -2, Z carbon -3. You should draw the structure. If you draw the structure, you can identify that easily. Just I am drawing the structure. This is the structure of propane. What's the oxidation state of this carbon? Okay. From this bond, 0, 0. From this bond, +1, -1. From this bond, +1, -1. +1, -1. Okay. So totally -3 plus 0. -1, -1, -1, 0. So what's the oxidation state? -3. And this carbon 0, 0. +1, -1. +1, -1. So what's the total oxidation state? Sorry, what's the oxidation state? -2. Likewise here, same as this, right? -3. Right? Got it? How can you say this is +1 and -1? How did you say hydrogen plus and carbon minus? Just by considering electronegativity. How did you say +1 -1? Considering the number of bond. Right? Number of bond. That's all. So these are the oxidation states of each carbon here. And what's the oxidation state of oxygen? This oxygen 0. And what's the oxidation state of that carbon? Carbon dioxide +4. Right? It is +4. You want me to explain that? How it got +4? No. Okay, it's +4. And what about water? oxygen minus oxygen minus here carbon plus 4, oxygen minus 2, right? Carbon plus 4, oxygen minus 2. There, oxygen minus 2. Oxygen minus 2, hydrogen plus 1. Here also hydrogen plus 1. So you don't need hydrogen, right? High oxidation state of hydrogen does not change, right? So hydrogen has no role in this reaction, right? Hydrogen has no role in redox reaction. Redox reaction means what? Electron transfer. So hydrogen has no role in electron transfer, right? Okay. So carbon minus 3, minus 2, minus 3. Here plus 4, right? So no doubt carbon, oxidation state of carbon has increased. Why? Minus 3, minus 2, minus 3. Oxidation state of oxidation state of any carbon atom has increased, has decreased? No, all have increased. Minus 3, minus 2, minus 3. Here plus 4. So oxidation state in the product is always greater than the oxidation state of reactant. So carbon is undoubtedly underwent what? Undergone oxidation. Right? Okay. What about oxygen? 0. Here oxygen 0. Here minus 2, minus 2. So oxygen definitely underwent what? Reduction. How many electrons? Carbon. How many electrons has been lost by carbon? How many electrons? Okay. There is not a single carbon, many carbon. So you should calculate the cumulative oxidation state, right? What's this? Oxidation state of each and every carbon. You should know what? You should calculate cumulative oxidation state. That means sum of the oxidation state. What's the sum of the oxidation state? Minus 3, minus 2, minus 3. What? Minus 8. Sum of the oxidation state is called cumulative oxidation state. Right? Minus 8. There. What? How many carbon? Oxidation state of one carbon is plus 4. How many carbon is there? 3 carbon. So what? Plus 12. So 12. How many electrons have been lost? Minus 8 to plus 12. How many electrons? Just think. Minus 8 to plus 12. Minus 8 to 0. How many electrons? 8 electrons. Then 0 to 12. Another 12 electrons. So totally 20 electrons. Right? Carbon has donated or carbon has given 20 electrons, and such 20 electrons will be gained by this oxygen. Okay, so just see the oxidation state of oxygen. What's the cumulative oxidation state of oxygen? Yeah, it's always 0. Why? 0 means 0. Right? 0 ever multiply on 0, right? The cumulative oxidation state of oxygen. Minus 2 into 2, minus 4. Into 3, minus 12. 4 into minus 2, minus 8. So, minus 20. Right? Oxidation 0 to minus 20. So, it has gained 20. Right? If you balance the reaction, Then carbon 12 electron release per unit. So oxygen should definitely gain such 20 electron. Carbon has lost 20 electron means what? Such 20 electrons should be gained by oxygen. So actually we don't need to calculate the number of electrons gained by oxygen. It's 20, you know that. Okay. You have nothing to write. All are in the tube, right? All have been given in the tube, right? And then example 3, formation of propane from propene. Formation of propane from propene. CH3 CH double bond CH2 plus, I have drawn the structure in detail here, right? Okay, plus what? H2 product CH3 CH2 CH3, right? Okay, and yeah, I have balanced. The reaction has already been balanced, right? What's the oxidation state of carbon? X, Y, Z. X carbon, Y carbon, Z carbon, and what else? Hydrogen. Oxidation state of X carbon, what? -3, right? Oxidation state of this carbon, -1. Why? It's connected to one hydrogen, and this side carbon, and this side carbon. So from this side, oxidation state 0. From this side also zeros. So its oxidation state is -1. Only one CH1, so one carbon and one hydrogen. From that bond, it gains one minus, right? And here, what's the oxidation state? -2. What about hydrogen? +1. Oxidation state of hydrogen is +1, right? And this hydrogen, okay, 0, its element, so 0, right? There. What? X carbon, Y carbon, Z carbon, right? And now I've given X carbon -3, Y carbon -2, Z carbon -3. Yes. Hydrogen what? +1. Okay. Now cumulative oxidation state, right? Okay. What's the cumulative oxidation state of carbon? -3, -1, -2. Carbon -6. Hydrogen plus cumulative oxidation state of hydrogen. What? Here only carbon and hydrogen. What? Oxidation state of one hydrogen is +1. There are 6 hydrogens, so +6. Okay, it's 0. Okay. And what about here? Cumulative oxidation state of carbon -8. Hydrogen +8. So what can you say? Okay, cumulative oxidation state of hydrogen here is 0, right? Okay, I'll write it as 2 into 0. Right, 2 into 1 is 0, so 2 hydrogen, 2 into 0. Yeah, it's 0, always it's 0. Okay, for convention, right? What? Carbon, minus 6 to minus 8. So, carbon get reduced. Carbon get reduced. Right, carbon had minus 6 to plus minus 8. Carbon gains electron, right? Oxidation state decrease, so carbon gains electron. How many electron? 2 electron, right? Hydrogen plus 6, 2 into 0. Here plus 8. So initially plus 6, now plus 8. What you can say? 6 hydrogen remains unchanged. This 6 hydrogen remains unchanged. Same plus 6. Additionally, these 2 hydrogens initially in 0, and here that 2 hydrogen will be combined with this compound, and the oxidation state of that 2 hydrogen becomes plus 1 and totally plus 2. Totally plus 2. Cumulative oxidation state is plus 2. Right? So what? Hydrogen get oxidized. Hydrogen get oxidized. Got it? Plus 6 to plus 8. That's all. Plus 6 to plus 8. So hydrogen oxidized. How many electrons? 2 electrons. Yeah, carbon 2 na hydrogen 2 da maro no. Definitely. Right? Got it? Okay, note it completely if anything is missed. Sometimes hydrogen is not given. Okay, if you want, you can write that.